All right, so if you look at 11-2, number 46. No way. Even chose x squared plus 6x plus 4. So if you put that in the calculator, all right, and if you graph that thing, what's up? Oh, yes.
How do you reset this? I messed it up a little bit.
Zoom 6.
Do you have a list?
Oh, these guys. Yeah. I'm gonna finish up in a minute. All right, is everybody with me that wants to play along? This is 11-2, number 46. Yes. Okay. So let's all. What do I hit to make sure my window isn't all freaky? What do I hit to make my window start off normal?
Zoom 6.
Yeah, Zoom 6 because that's Zoom standard. So if you hit Zoom, right in the middle up there, Zoom 6 is the standard window. All right, and sometimes, of course, the standard window is not good. I got to move that sucker around. We talked about moving the X-min, X-max, Y-min, Y-max, all that kind of stuff. So you can actually see stuff. I can see everything I need to here. I see all the important shit. Can anybody tell me what I see? What do I see? What's all the important shit? Vertex, but intercepts. I like it. Line of symmetry. Vertex is also known in this case as the minimum. I like it. Sweet. Yeah, I see that there's two real solutions, and that's what this question is asking about. What are the solutions to where this equals 0? Now, of course, if I said, where does this function equal 0, why does it just make sense that they're the x-intercepts? Yeah, it's where they get a 0 output. Where's the function equal 0 is where they have a 0 output. They must have a 0 output here because the y part of this is 0. And y is the output. I like it. So that's why when they say, what are the solutions to this quadratic equation? You end up finding the x-intercepts. That's what quadratic formula does, is it finds the x-intercepts, which happens to be the answers to ax squared plus bx plus c equals 0. All right, cool. I like it. So how the hell do I find those intercepts? Trace is not good enough. I want to know the exact answers, or as close to the exact as it can get. A decent approximation. So how do I find, let's do this one first. So what am I trying to do right now? I'm trying to make the calculator do what? Give me the numbers. Find the numbers. Calculate the x-intercepts. So that's why it makes sense I'm going to go above trace. See right above trace? So every button up there has to do with a graph somehow. Tables and windows and shit and trace. So calc means it's going to graphically calculate something. Something that I see on the graph. So if I go to second trace, I can see which one I want. What do I want in this case?
Intersect.
Not intersect. Not value. 0. Right? This is where the function is 0. Intersect is if I have two functions. How many y's did we just put into the calculator? 1. I just put one equation there. It's not going to find me intersections between anything. Value is making x equal something and getting what y is. I know what I want y to be. It's x that I don't know. So value is the exact opposite of what I want. I want to know the zeros of this function. That's why the second one is for x-intercepts. The zeros. Where does it hit the ground? Where's the height above the ground? 0. So I always think about the x-axis as the ground. So if we do 0, it's going to ask us 3 questions again. So I always tell people, because left and right get a little freaky sometimes with certain functions, put your cursor on the answer and then hit the left arrow to get the answer to the left bound. I want to be a little left of the answer. I'm going to try to give it an area to search in. Right? It's like The Fugitive. They knew how much time had elapsed since you guys have seen The Fugitive, right? The movie? Is that before your time? You're like, that's back before they had CGI for real. That's back when the shit was look good. But the guy escaped. They had to have a search perimeter, so they had to know how far to search in. So I'm trying to tell the calculator right now how far to search for this thing. So I'm going to go a little left of the answer. Pop, pop, hit enter. Then I'm going to go to the answer and then go a little right of the answer. Bam. And then I want to try to get right on the answer for my guess. Bam. So what's the answer? What's that x-intercept? Good. Stop. Y equals 0. Of course it's 0. That's what we forced it to be. The answer, this answer is that one. Now do the same thing to find the other one. That's how you get that problem. 11.2, number 46. That's how you use the calculator to get the intercepts. To get the solution for that equals 0. Is everybody cool with that? If I wanted to find the vertex here, what would I do? In fact, let's do it. Let's predict what it's going to be before we let the calculator do it for us. Who remembers the shortcut to find the vertex? Yes. Here we go. Some good ones. Some of you guys remember. Some of you guys just now heard it for the first time. But x equals negative b over 2a will give me the x piece of the vertex. Short answer why that is because the vertex will always be right in the middle of the two intercepts. And what gives me the intercepts is the quadratic formula. And what's right in the middle of the quadratic formula? Negative b over 2a. Because it's negative b plus or minus shit over 2a. So that's right in the middle. Negative b over 2a, give or take that. Does that sound familiar?
That's the vertex?
That's the x piece of the vertex. That was a really quick rundown of the lecture I gave last time about why that is. So, of course, I'm going to get the x piece. How do we get the y piece? Whatever I get here, I just plug it in. So what would I get? So what's b? 6. What's a? 1. So x is negative 3. If I plug that in, I get 9 minus 18 plus 4. Negative 9 plus 4. Negative 5. So let's see if that's what the calculator does. So what am I going to do to find that vertex? What am I going to do up here in calc? Which one of those am I going to do? There's no vertex option. What the shit? Well, this is where we as humans come in and say, calculator, gotcha. Your technology, that's great. We can't do this shit. Which one of those am I going to use? Because what is the vertex in this case? It is also known as the minimum. So I'm going to use the minimum. If it was an upside down parabola, I would use maximum. I like it. The reason they don't have a vertex option is because, is this parabolic? Is that a parabola? No, it's got way too many turning points. This is like a crazy-ass polynomial, x to the 6th or something. But I can still find the mins and maxes. I'm going to have a whole lot more mins and maxes, am I not? I'm going to have a whole bunch of mountains and a whole bunch of valleys. They're not vertices, they're not vertex. That's not what they each are, but they are mins and maxes. So it's a more general way to say it. So if we go to minimum, number 3, and again, it's going to ask me for a little area to search in. Go to the left of it. Go to the right of it. See up here? Little area to search in. And then if I go right on it, as close as I can get, let's see what it tells me. Yay! Why is that cool? Okay, did it tell me negative 3? Not officially, but that's it trying to tell me negative 3. It's just a calculator. The things it does are not as good as the things we do. I hope you sort of understand and believe me. See, look. It must do shit that it didn't need to do. We know the exact answer is negative 3. It's like, I think it's about this. That's the best it could do. But when you see something like negative 1.999 or negative or 12.9999, it's trying to say 13, right? It just can't resolve it that good. Is everybody cool with that? Yes?
My premise is error found.
Yes, you didn't give it a good enough search area. Yeah. Make sure you go to the left of the answer, to the right of the answer, and then get right on it for a good guess.
Okay.
Yeah.
So does it really matter how far you go from the left or the right of it?
It could.
It starts in the middle.
Oh, sweet.
So I don't know if it goes down.
Your
like this or
calculator's
that.
too good. Yeah.
Does it go that way then?
Huh?
When you start it out, does it matter which side you start to?
Did it even ask you left and right, or did it just give you that?
It just put it in the middle and had you move it, so
Oh.
so I wasn't sure where to.
You're good.
So left or right, it doesn't matter.
Yeah. Yeah. That one I got to take a look at. It might be able to do a little too much.
Okay.
Yeah. Yes.
Yeah, that's okay.
Minimum. Go to the left a little bit. Enter. Go to the right a little bit. Enter. Get right on it. Enter. Not sure what you're doing. You gotta make sure you go the right way. If you flip it, it's gonna freak out.
I did.
Okay.
So
read
left
this.
and right.
To the left, and enter. To the right, enter. Yes, enter. Yeah. And again, the whole procedure is on that sheet that is on the website that you can print out for yourself. If you want to be nice for yourself, right? I'm already mean. You should probably be nice to yourself. Okay? Let me think. Is there something else real quick? I think that was it. Yeah, that's it. Sweet. I like it. All right. Okay. So anything else left over from homework we haven't talked about yet? Okay. Little dude, you could do it. There you go. Yeah.
I tried to get into the again to the same page and look.
Oh, it just, they don't have anything for section 10.8, I guess. Does it only not work for 10.8? We tried other things. They work for every other section.
Before that section, yes.
Have you tried after that section?
It has nothing after that. This
all
was
right.
like 2 days.
All right. Well, that's the problem with my math lab. I gotta send them an email or something. You gotta remind me.
Okay.
Okay. That's why I don't generally like using that, because that adds a whole extra level of shit that I got to deal with. Some program I didn't write. I hate it. Sorry. That's my online homework. Ooh. Okay. This kind of leads right into the stuff we're going to get into today. We're going to finish up chapter 11. I think we'll talk about this section, then we'll take a break. Then we'll get into chapter 12. So remind me, if I find, how many ways have we gotten so far to find the vertex? You can tell me. Yes? Huh? Oh! All right. Tell me what are the ways. Don't just tell me the number of ways. Does anybody tell me one way, like the way we just did? Calculator. I like it. So one way is make the calculator do it. And find the vertex. All right. The other way is the negative b over 2a way that we just did. Negative b over 2a gives me the x piece. Plug it in to find the y piece. I like it. There's another way.
Parentheses h plus k.
Yes. Yes. Take ax squared plus bx plus c, put it into a times x minus h squared plus k form. Oh shit. Right? And this is completing the square. Complete the square to do that. Then the vertex here would be what?
H, okay.
H. Okay, I like it. And of course, out of this list, the one, if I can read you correctly, me too, I would freaking like to do that. Yay. Unless I tell you you have to do it some other way, that's the way I would hope you would do it. Because that's the easiest freaking way. Right? It's the way that uses the most conceptual stuff to get there. That's why a lot of the work has been done already. That's why that's the quickest way. Maybe. Now, of course, make the calculator do it, is never an option normally, unless I tell you use the calculator like we just did. I like it. So this is the way that you definitely want to do it in section 11.8. And what section 11.8 is, let's see if I can say, I don't know if I've already told you this. 11.8 is like the quadratic, let me say it a different way. They're called optimization problems. You want to maximize your profit. You want to minimize the amount of paint you're going to use. And those sound like maximum, minimum. Those sound like locations of vertices, right? The vertex. So these problems are going to involve you setting up an equation and then just finding the vertex. Right? So they are word problems. But try to couch it. Yay.
No, I said Jack.
You said shit? I heard you say.
Two sections
You got
of word
selective
problems
here.
in this chapter.
Huh?
You got two sections of word problems in this chapter.
Yeah, you're welcome. Yes, I
I've
knew.
always wanted.
Now I don't know what this is used for in real life.
No way. I mean, that's horrible. I'm sorry. You still really won't quite, but it's getting closer. The more math you learn, the closer you get to how it can really, really be used in a true situation. Right? I mean, that's just the bottom line. That's why so many word problems early on in math sound so stupid. Bob forgot how much money he put in the bank. What the shit, Bob? Right? Bob's got problems. Well, maybe he's got problems I wish I had. How much money was that? 40,000? 50,000? I would know exactly how much. All right, so let's give us a nice example.
I wish I had that problem.
Yeah. So here, let me see. So let's say we got a beach somewhere, and we want to put out these like protective nets that go underneath, so to try to keep sharks from coming in there and eating people, right? Maybe not the Meg. I think that's the most hilarious name of the movie I forget. Shut up, Meg. So let's say I want to maximize the area here, and this thing that I've got to put out in the ocean, I can't cut it. Let's say it's 80 meters long. All right. So you're going to have to draw the situation and then identify variables. I want to maximize the area. Now imagine if I had an 80-foot length of something. How many ways can I create a three-sided like rectangle like that? How many ways I can lay it out and then kink it, right? So I could make it like, I want you to really understand what's going on here. I could make it really narrow, like make it long as shit, right? That'd be a very interesting, weird shape. You guys with me? So that would be like a lot of beach area, but very little room to like move around in the water. Or I could do the other extreme where I have, there you go. Right? Which doesn't seem very conducive to anything. People coming back in are going to be hitting people coming back out. You're like, oh shit. So somewhere there is a best place, a best way. Maybe make this a little bit, if it wasn't so long, maybe that's a little bit better. But somewhere there's like a best dimensions. That gives you the biggest area to play in the middle. Are you guys kind of with me? That's the idea of every problem in this section. It's not always going to be like laying rope out in the ocean, but it's going to be somehow there's a way to construct this or to use things that makes the output the best. Yes?
Wouldn't that always be a square?
No, I love it. If I had four sides, it will always be a square that maximizes things. Maximizes the area, always. The minute I have less than four sides, right, this makes a rectangular shape, right? But one side I don't need rope on, because as far as I know, thankfully, there's no land sharks. Just an old Saturday Night Live skits. You guys with me? So I don't have to use this side. That's already there for me. That's the beach. I don't need that. Yes?
So you wouldn't like make it like X or anything because you don't need it at all?
Yeah, I'm only going to put the variable down where I have to control things. I mean, the same thing as if I had a house and I wanted to build a pen off the back for my dog. I don't have to use anything here because there's already the wall of the house there. So I like it. That was a really good observation. I mean, that's the thing you learn if you do enough of these. You're like, if they do give you all four sides, it's always going to be a square. All right. So, and I don't know if you caught on. I think I said more than four sides, or did I say more than four sides? Yeah, because I could say I want to construct something like this, where the inside thing gets counted now, because I actually have to build that sucker. So we could have something like this, and it's not going to be square overall either. Okay, now, so how long is this side? Do we know?
No, besides
It can't. If it was 80, then I've got just a big piece of rope out. I've used all my rope for that one side. And it's like, we're playing on this, and we're like, sharks, please don't swim around and kill it. Can you just be nice?
So we have to divide the 80 like
No, don't overthink it. Do you know how long this side is? No. So we call it X. I love it. So how long has this side got to be? It's got to be X. Don't make it freaking Z and freak yourself out. It's got to be the same length because I want to make a rectangle here. And so how long is this side then?
And that's the same as the
2x.
Why twice X? Why not 3X? Why not 15X? Why not
X
half of
squared.
X? Why not X cubed? Why not X to the 18th? No. Do I have any clue what this is? Does it have to be related to this directly?
8 minus 0.
Okay, let me just say, okay. Y or something, right? These two have to be the same. Does this one have to have any relationship to this one?
No.
Not necessarily. They are related eventually, but not directly yet.
Let's make it Y or an X.
Why?
That's a Y.
Okay.
Definitely does not have to be the same length. Because if I just gave you a rectangle, what would you call this side? X, and you call this side Y. So all I've done, and this side is Y, this side is X. With me? So what's the only thing I've done? Oh yeah, I don't need that side. That's the only thing I've done in this problem. I just don't need that other side. I don't need to put something down there. So my 80 meters, is not going to be counted here. So I got X meters of rope here, Y meters of rope here, and then another X meters to complete the shape. Okay. Okay, that's not supposed to be a hard side. All right. Now, what is the overall relationship here? How does 80 come into play now? Y plus 2x, right? Doesn't this whole thing have to equal my 80? Of course, so somebody will lay the 80 meters down. Does that make sense? That's what do these represent? The length of this rope stuff that I'm laying out. So all together, the whole length, x plus y plus x. Y plus 2x has to be the 80 that I'm working with. Not a big deal. This is not the hard stuff yet. So they're always going to tell me something. They're going to give me some relationship. So what they told me in this case was the 80 meters and the shape. So I can put that together to make an equation. And then they're going to ask me something. Now, who remembers what I'm trying to do with this? What's the ask me? What do they want me to do? They want me to maximize something. Who remembers? The area of it, right? I'm going to have the biggest area to play in. What is the area of this shape? Say again? X times y. Yes. Sorry. I was trying to make sure you weren't saying x cubed y or something. So area is just x times y. There's nothing amazing up here. What's happening? We've done this kind of stuff before. What we haven't done is this next step. Can I use what they tell me? Because this is information they've given me. In what they ask me. What can I do with this to help me with this? This sucks. There's too many letters here. What can I do with this to help me with this? What can I do with this?
Can you do like subtract 2x?
Yes, I can solve this for y. If they give me information, I want to use it. So they're going to tell me something. Now, they're not going to tell me the equation. They're going to tell me information that I can write an equation about. That's what they told me. Then they're going to ask me something. I love this idea of tell me, so you focus all your attention on what did they tell me. Let me draw the picture of what they told me. Let me write an equation of what they tell me. Then they're going to ask you something. Maximize this. Find the way to get the biggest this. Find the way to make the cost the least. And you're like, that's the equation I want to make. So here they said maximize the area. Okay, here's the equation of the area. How do I use what they told me with what they asked me? Well, I can solve this for y. And then what can I do? Plug it in. Area is x times y, but y is 80 minus 2x. And what kind of equation do you end up with here?
EDX minus 2x squared.
Yep. And what kind of equation is that? What kind? Quadratic. So they're trying to find the maximum area. Can you tell me anything about this parabola? What would it look like? Is it opening up or down?
Down.
Definitely down.
It's because it's negative?
Because the negative in front of the x squared. I love it. So it's a down parabola. Would they have a maximum?
No, they haven't.
A down parabola does not have a maximum.
Oh, yeah.
Okay, let's try again. That's the top of the hill there. So if it was cost, it would probably look like something like this, so there's a minimum cost. I like it. Yes?
I thought that the negative 80 would tell us if it was up or down.
So it's exactly the same thing as the mistake people make when I ask them what's the slope of this and they say 7. What mistake has that person made? Do you realize it's a mistake? Is the slope of this 7?
No.
Hell no. Why did they make that mistake? What mistake did they make? What is the slope? Negative 2. How do you know the slope is negative 2? Because it's in front of the freaking x. What's wrong with this equation then? It's out of order. Not really. It doesn't matter what order it's in, but you get so used to the first number being the slope, you just say it. You're like, 7. No. Negative 2 is the slope because it's in front of the x. What's a here? Negative 2. What's b? 80. The number in front of the x squared piece tells me if it's up or down. Not the first number, just the way anybody wanted to turn it around. If I wrote this like this, I didn't magically turn the thing upside down. Those are the same equations. So you can't, do you understand what I'm saying? It can't open up just because the 80's first and now it opens down.
So it's in the ax squared plus bx plus c format?
Yes.
Supposed to be?
Because what's c?
0.
0, which is fine. I like it. Okay, again. Yes?
You can also look at it as like which variable has the biggest exponent to the least, and you make it left to right.
Yeah, you put it in decreasing form, yeah. Anything in front of the x squared piece is going to tell you how it opens up or down. That's a. That's what a's job is. Anything in front of the x term is b. Any number by itself is c. I like it. Okay, so if I'm trying to find the biggest area, where is that going to occur on the graph of this? Where will it occur? At the vertex. And what's the quickest way to find the vertex? Negative b over 2a. I love it. So what is, so again, a is negative 2. B is 80. So x equals negative 80 over twice a. So you get negative 80 over negative 4, you get 20. So this side is 20 meters.
The other side is 20 meters.
Of course that side's 20 meters also. Now, I want to know what that is.
40.
Plug it in.
Yeah. Y is 80 minus twice 20, so 80 minus 40, 40. Some of you guys might get this Do you see how that's half?
Yeah, that's what I was just
So if I had 3 sides in there, there's a relationship you can figure out ahead of time, but you might as well do the work to get it all the way out. But it does try to square it still. The total length here is equal to the total length in this direction, always. It's kind of nifty.
Because in that other picture, you're basically going to have a 22 relationship.
Yes.
This is where you have it.
Beautiful. Okay, all right. Don't worry about that part. You don't have to know ahead of time what the answer is going to be. Never. But it's nice if you do.
So what she said is just it's half of the other ones? Is that what you just said?
Don't worry about that part.
Okay.
Yeah. Like I said, if I gave you all 4 sides to play with, the answer will always be a square if it's just talking about dimensions. I could throw extra shit on there like I do for my calculus students, and I say one side costs this much more than the other sides. Then it's not a square anymore to make it minimum cost to put it together. Every problem in this section wants you to set up an equation and then find its vertex. That's the goal of these problems. When they say maximize the profit, you think I've got to get a profit equation so I can find the vertex. Minimize the blank. I've got an equation for blank so they're going to find its vertex. So they're going to use the stuff they tell you to help you put together the equation for what they ask you, just like we did here. Let's do one more and then we'll take a break. Let me take one right out of here. Let's do a different type. Well, this, okay. I like this.
What number is it?
I don't know, I'm going to make one like it. I just want to see what kind of problems they had. Does anybody got what they want from this? More than you wanted? Real quick, before I do this, I want to give you an example of this in real life. When you see silos that are holding grain or something, I know you've all seen these. You know, the minute I say silo, what shape comes to mind? Cylinder. Circular base, right? Repeat it up. That's the cylinder. Why didn't they make a big rectangular shape?
Circles are stronger.
Yeah, that's one point. Circles are stronger, but let's say we're in a section of the country that no earthquakes, no big wind, you know. What's funny is I can use the same amount of material to make a circle base and repeat that and have a larger volume than I could for any box I make. So as long as the stuff I'm putting in will fit nicely into a circular shape, like little grains or something will fill it all the way up, circle is the best shape to use. You'll get the maximum volume then compared to any other shape. So you can actually use math to prove that. Now, of course, this always gives people the wrong impression. Math came and verified that, but people kind of figured it out through trial and error before that, right? But math can come in and improve situations where we don't have that ability to experiment enough to see what the real best shape is. Okay, so let's do this one problem. Yeah, let's do one like this. I like it. Right, I mean, that, hopefully, I am not a business person. That was the lowest score I got on my little aptitude test was anything related to business. I'm like, that sounds about right. I don't want to have anything to do with it. I don't want to make, sell, or produce anything. But profit definitely is revenue minus cost. Profit is the money you make minus the money you had to pay. I mean, that makes sense. So if I give you an equation for revenue, see my revenue is 1,000x minus x squared. And my cost, let's say, is 3,000 plus 20x. So let me give you a situation. The cost makes sense because let's say you have a little area in which you make some thing, right? You make widgets. So it costs $20 per thing in materials, plus you got to pay rent and water and stuff to have going to this little factory you've got. You guys with me? So this is like what's called overhead. And this will be your price per widget. That's what goes into the cost. I like it. And then the revenue is $1,000 per thing, but then it's got to do also with if you get too far out, this is a little more complicated, but if you get a little too far out, you start losing interest if you push your price too high or something. There's a lot that kind of goes into this minus x squared piece. You'd expect the revenue to be like this. Otherwise, you just sell as much as you could and just it would go forever up, which doesn't happen. There's kind of like a breaking point. Yeah. So what would the profit function look like then? How would you get the profit function put together? This problem is nowhere near as bad as the other one. They gave us everything that we needed. They reminded us this is true. So it'll be...
1 plus R.
What's happening? All right. What's the revenue?
It'd be 1,000x minus x squared
Good, that's the revenue.
minus 3,000
Minus-
plus 20x.
Revenue,
Minus
revenue.
cost.
Minus cost. It's not that crazy. You just plugging stuff in. Right? Are you guys getting stuck on the parts you really shouldn't? The one part I thought you had trouble with here is don't forget the parentheses. You got to subtract the whole cost, not just part of the cost. You got to put parentheses around that sucker. So if I kind of work with this a little bit, I get 1,000x minus 20x is 980x minus x squared minus 3,000. So now you just got to identify the, you can put it in descending order, or you can just realize the A and the B where they're supposed to be. What is A in this case?
X squared,
-1. It's always the numbers, the coefficients. What is B? 980. And what's C?
-3,000.
-3,000. What kind of problem will this be?
Upside down.
Which makes sense because they want me to find the maximum profit that I can make. We wish it would be like this if I was a business, because I'm like, oh, if we just keep going, we're just going to keep making as much money as we, oh, yay. But it goes like this, it's a sweet spot. Sweet spot. All right. So how do I find the maximum now? Yeah, sure. I love you guys. The maximum is going to occur at the vertex. The vertex, the way to find the x piece is negative b over 2a. So negative 980 over twice -1. 98 divided by 2 is 49. So you get 490. What does 490 represent? Let me stop right there. What's 490 by itself represent?
X.
Yes, x. What's that mean physically?
Isn't it an input?
Physically. Does that mean the weight of turtles in Guatemala? What does that represent? Physically. Does it mean the amount of money that Joseph that works in Toronto makes on Tuesdays? What does that mean? What does X mean? The number of things, right? X is the number of things I make. So 490 things. What does that mean? So if I make 490, if I make and sell 490 of these things, I'm going to maximize my profit. Now what if I said, what is that profit going to be? What would you do? How would you find, how much money will I make for 490 things? How much money will I make? Do we have a profit function up here?
Yes.
Yes. And what do I need to know to figure out a profit? I need to know an X value, don't I?
Yes.
Do I know an X value?
Yes.
Yes. So to know the profit for 490 things, I put 490 into the profit function, right? So you could plug that in the calc. I love you guys. There's nothing amazing. All right. We definitely need to take a break. So 980 times 490. I just plug a 490 in. to figure out what the profit's going to be. That's what that function is for. It's the profit function. Minus 490 square, minus 3,000. What would that be? That'd be 2. 490 squared, so it'll be 1. 490 squared minus 3,000. You guys going to make me do that?
48,000 or 480,200 for that first one.
Oh, just for this?
Just for that, yeah.
Oh, I see.
I thought we were doing
I'm with you.
step.
You're fine.
Want the whole thing.
Cut that in half. So 240, 100. So 237, 100.
Yeah.
Yeah.
So that's the profit you would make if you did sell that many things. Now, how can you check now? Oh boy, let's see if I could push this. I don't know if you guys are just not answering because it's too obvious, or if it really is completely out of your ability. Yes.
So basically you just plug it in 490 into the x equation.
Totally.
But,
If they, yeah.
but why didn't you plug in 490 into 20x?
All right. So do you see how that's here? 1000x minus 20x is 980x. You see that?
Yeah.
So I used, these are both the same equation.
Oh,
So if you use this one, you get the same answer we did, but we just have one less thing to worry about.
Yeah.
I like it. What was I about to say? Oh. So this is supposed to be the what?
Profit.
The most profit I can make. How do I check that?
You plug it in.
Plug that in where? What do you mean?
Profit.
No. Not check to make sure the number is right. Check to make sure that this is the biggest. If I say you can't use a calculator, how would you do it? What if you sold 489 things? I know I'm pushing it. We could barely make it through this, but can you plug a 489 in to this equation? Just on your calculator, guys. So what's 980 times 49? Can you do this for me? If I made 489 things, is it really less than that?
$489 or 490.
We already did 490. We already did 490.
489 is 479,220.
The whole thing?
Oh, you want me to do the whole thing?
I got.
Yes, I wanna know what the profit is.
237,099.
Say again?
237,099.
Yeah.
Yeah.
Which is $1 less than this, right? Which is less than this. And if you plugged in a 491, it'll be a little less than this. Which is kind of like, not proof, but it is nice evidence that that is the highest point. A number right next to it is a little lower. A number right next to it is a little lower. That is exactly what should be happening at the top. If you go either side, it should be a little lower than what I got. That's a nice way to kind of check to make sure, yes.
What happens if you raised it? Like instead of 489, you did 492?
Same thing would happen. Yeah. In fact, if you put a 491 in, I'll bet you $1 million you get the same number you got there. And I'm a teacher.
That's cool.
Yeah.
I like that you have $1 million.
Huh?
I like that you have $1 million to bet.
I didn't say I did. I don't need to have $1 million because you didn't tell me to show it. Just do the numbers and you'll see it's the same thing. How do I know it's going to be the same thing? Because we just proved this is the vertex. So if I move one step over and get a certain number out, if I move one step over in the other direction, I have to get the same number out, don't I? Mirror image. See how it all comes back together. That's why I feel so confident saying that when I don't have anywhere near $1 million. It don't matter. If you take me on a bet, you better worry that you have $1 million. Don't be taking me up on a math bet. That's a good way to go. All right. Let's take a break while we all figure out what's happening. You guys come back from the weekend fully? Is that what's going on? Or what? Glad you're physically here. I like it. All right. Come back. Let's see. Come back at 15 till.
I have a question for Jim.
Oh, yeah. I always hate when I do this. Somebody want their ID back right now?
Calculator?
Probably. I feel. All right.